Hello everyone, I am Subham from IIT Bhubaneswar and in today's lecture we will discuss about the acidity and basicity. Okay, before going to the question, let's understand a concept, that is, if a compound is acidic in nature, and then after giving the hydrogen, let take an example like ROH. Okay, now after giving, and another one is carboxylic acid. Okay, now after giving hydrogen, now it is acid, and same carboxylic acid convert into anionic form and cationic form acid. Now how to decide which is strong acid and which is weak acid? Okay, let's see. If the negative charge is stable more, then the complex will be more acidic, because here Ro negative, it is stable because it is on more electronegative atom, and here it is also on more electronegative atom, plus it have also a resonance, so it will be more stable. That's why it is, second one is strong acid. Okay, so strong acid second. So now let's solve the question from MS Sohan book. Now we have 395th question. Which of the following compound has the most basic nitrogen? First we have second, okay. Now here this nitrogen have lone pair, plus there is no conjugation or any sp2 hybridized nitrogen. Okay, and here have nitrogen have lone pair, but it is in conjugation with double bond or carbonyl group. Here also lone pair, but that is not furry, they are in conjugation with carbonyl group. Same here. So we can see here the option A have the furry lone pair, that's why it can donate easily. So basicity is directly proportional to how easily a lone pair can be donated. So option A is correct, that is most basic. Now the next question we have, compare acidic strength of CHCl3, CHF3, CH3, CH3. Okay, CHCl3, CHF3, CH3, CH3. Okay, now here after giving CHCl3, after giving H positive ion, it will be CCl3, and it will be CF3, and it will be CS2, CS3. Negative charge, negative charge. Now fluorine have absence of vacant d orbital, but chlorine have vacant d orbital, and so we can say it have vacant orbital, so easily the negative charge will be more stable here. But as in fluorine there is no vacant orbital, vacant d orbital, that's why it is less stable than CCl3 negative. And after that here plus I effect is dominant of CS3, that's why it destabilize the negative charge, because it have only it have also negative charge, and this methyl group also donating some electron, that's why it leads to the higher instability. So more the stability of conjugated acid or base, more will be acidic strength. Okay, so that's why CCl3 negative is the most basic, then CF3 negative, then most acidic, sorry. So option A is correct. The next question we have, that is concept of Bronsted base and acidic. Okay, Bronsted base or acid, which can accept H positive ion, that will be Bronsted base, and which can donate H positive ion, which will then it will be Bronsted acid. Okay, now take an example. The strongest Bronsted base among the following compound is NaCH3, NaOH, NaF, NaFH2. Okay, NaCH3, NaOH, NaF, NaNH2. Again, let's draw. It can be Na positive plus CH3 negative. It can be Na positive, OH negative. It can be Na positive, F negative. It can be Na positive, NH2 negative. Now you can see here oxygen, fluorine and nitrogen. These are the most electronegative atom. That's why the negative charge will be more stable on oxygen, fluorine and nitrogen because it is also electronegative. So, but on carbon, which is less electronegative, or we can say electropositive in character, that's why negative charge is unstable on carbon, and it is also sp3. That's why it is highly unstable. So we can say it easily, but it want to catch the hydrogen, so it can easily accept the hydrogen to gain stability. That's why we can say NaCH3 is the strongest. NaCH3 is the strongest base. Okay, so option A is right. The next we have, which of the following has lowest pK value? What do we mean by pK value? pK value is inversely proportional to the acidic strength. Okay, and we can say Ka. Ka also leads to the acidic strength. So if we have a species which have highest acidic strength, then it will have lowest pK value. Okay, so let's take an example here again. That is 403 question. Which of the following has lowest pK value? First we have Cl, CH2, CO2H, then Cl2, CO2H, then Cl3, CO2H. Okay, here we know chlorine exhibit minus I effect, which pull out the electron from any carbon ionic species. Okay, so after drawing its anionic form COO negative, now here Cl2CH COO negative, again Cl3 CO2 negative. You can see here the negative charge will be more stable here because here 3 chlorine atom, that's why they exhibit more minus I effect, that's why it is more stable. So higher the stable anion after giving H positive ion, that mean this species is strongest acid, or we can say higher acidic strength, because after losing the H positive ion, if the species is more stable, that means it not catch the hydrogen again, that's why it is highly acidic in nature. Okay, thank you.